Meet Cassie, a black lab mix who loves to play.
We want to explore the dynamic system of a dog chasing a frisbee. We'll focus on the system from the dog's perspective and ignore the tricky airside math governing the frisbee's motion.
We want to know how a dog orients its head and body when chasing a frisbee. We'll only consider the 2D plane that is the ground, and we'll explore 3 important lines defining the dog's orientation. We'll consider the dog's head to be the dog's line of sight. We'll consider the dog's body line to be the orientation of the rest of the body besides the head. Finally, we'll consider the frisbee line to be the line from the dog's head to the frisbee at any moment in time.
Now let's talk angles. First, there's the angle between the dog's line of sight and the body line. Let's call this theta head bod. Next, there's the angle between the dog's line of sight and the frisbee line. Let's call this theta dog frizz.
Both theta head bod and theta dog frizz change continuously as the frisbee moves through the air. This is our dynamic system. If the dog chases the frisbee, the dog will constantly adjust both these angles. This is our controlled feedback loop.
We expected a dog chasing a frisbee to be a fairly simple dynamic system, with the dog constantly trying to minimize theta head bod and theta dog frizz. Cassie is a puppy though, and she isn't always motivated to chase frisbees. And when Cass does chase frisbees, she does it her way.
It's hard to quantify Cassie's behavior into precise mathematical formulas, but Cass does more or less follow a piecewise pseudo-equation of motion divided into one pseudo-equation for her behavior when the frisbee is high in the air and another pseudo-equation for her behavior when the frisbee descends near her height.
When the frisbee is high up, Cassie, if motivated, will remain in the same place while always seeking to keep her line of sight directly in line with the frisbee line. In other words, Cassie always tries to make theta dog frizz equal to 0. Sometimes this requires Cassie's head to rotate dramatically, increasing theta head bod to an uncomfortably large angle.
There are a range of comfortable angles for theta head bod to fall into, but if theta head bod begins to approach the limit of this range, Cassie will reorient her body until she is comfortable again, enabling her to keep her line of sight pointed towards the frisbee.
Once the frisbee descends to near Cassie's height, a new behavioral pseudo-equation takes over. Cassie still keeps her line of sight oriented towards the frisbee, but she now also begins to orient her body line towards the frisbee. Importantly, Cassie will also move translationally when the frisbee descends to an acceptable height. We in the dog frisbee community have a term for this. It's called chasing. In summary, when the frisbee is low enough, Cassie will run forward while attempting to bring theta dog frizz and theta head bod to 0.
The Cassie frisbee system is more complicated than we expected. Here are some of its properties.
The system is continuous rather than discrete. This means that the state of the system is subject to change over any length of time, no matter how small.
The inputs to the system are the frisbee's position and the dog's position and orientation.
Cassie, the controller, visually measures theta dog frizz, as well as the frisbee's height. She measures theta head bod using her sense of touch.
The important frames for Cassie are the frame of her head, the frame of her body, and the inertial frame.